Welcome to another video on my Raspberry Pi running Raspbian Linux, and as you can see, again trying to do pulses modulation with a camera that you can see with propeller, not a big one, and I have to keep in mind that there's a few seconds delay in what I do and what you see on camera. And an LED connected with this transistor. Here an LED, it burns but you cannot see it brightly, and there is this LED, well, LED here and an LED here. This burns, it doesn't yet, because the program is running. So still, why is the motor running while the program is running? Quite simply because of, for now, the voltage that's on it. If I measure, and that is the reason that I put the analog multimeter here. If I measure the voltage, that is right now over the transistor, and let me put the transistor a bit straight. So I measure the voltage as coming from the transistor, and you can see the needle move, and that moves to almost 4 volts. Now, for a motor to run, there's a potential difference needed. So if this is 3.5, almost 4 volts, what is then the power, the mains? And therefore I measure here, and that shows almost 5 volts. So that 1 volt potential difference is making the motor run. And that also, well, raise the question, what if I make the program run? So I am starting the program right now, and as a result you will see this LED starting to burn. If it is alright. No, it is not alright, because the wire is out. Ouch. And that should be, let's make it clear, that should be pin 7. So I have to put it in its place. Now it works. Now you see it burn, I mean. That is nice. So with the program running, it is also time to actually measure some voltages again. Now 5 volt is 5 volt, but want to know here what is on this one. And this is again 4 volts. Well, almost. The voltage is exactly the same. And the program just runs. And the voltage doesn't differ. And there's another one connected to it, and that's the other wire is also almost 4 volts. Now I can measure the voltage before the transistor, and that voltage is almost 5 volts, 4.5. So there is 1 voltage less after the transistor. Then does it matter if there is a transistor anyway? Well, yes, because it needs a potential difference to run something in electronics. So then, if that doesn't matter apparently, what does? I'm going to change the program again to see if that actually does matter. Now, yeah, let's do that. So, the program, last time I changed it, I commented all of this out, not being executed now, and it changes from 1500 to 0. And if you look at the motor, well, also with a last segment, it doesn't change anything. So I'm going to comment this portion out as well. And I am going to change here something. The point is, what should I change? Well, I am going to change this. First of all, the timing. 0, 10, 20. And then I'm going to say, okay, 50, 100, and 150. Let's see if that matters, if that changes anything at all. Save. Run. There was a hiccup of the video feed, but okay, I can't see any difference, to be honest. So I'm going to do something else. Or should I? Yes, I'm going to do something else. That is bringing things back to 0. So from 150, 30. This will be 100. 40. And last will be 50. 0. No guarantees, as ever, as always. So let's see. Removing the multimeter for a better view on the motor. But once again, is this I would expect now the multimeter to be away. So do I have to restart the feed? Ah, there it is. Even more delay than I thought. However, you can see that there is no change at all. So, what next? Well, measuring frequencies, which I cannot do with the analog one, with the analog multimeter. So in comes the yellow digital one. For some frequency measuring, because as you have seen on the site in my previous videos, this is really the way they say the hardware pulses modulation for the motors is working, and yet it doesn't do a thing, in my opinion. So next step. You have a multimeter in place, and I am starting the program. Now I have also noticed something else which I don't like, and that is as soon as this program is running, there is some more delay with the camera. So 4 seconds get even worse. Now let's see how this ends up. I'm starting it. There it goes. Now I will be measuring right from this probe, and it says now some varying between 150 and 200 Hertz. And on the camera you don't see it, the probe yet. Now you see it. So that means quite a delay. But also I do see that I get a varying frequency. So what if I do something else? That is a better idea. Stopping the program for now, and changing it, and I take this out. So that should be only one frequency, if my ideas are correct. So, starting it, one frequency only. Let's see once again. Do I get crazy results? Or only one frequency? And unfortunately, I don't see just one frequency. Yeah, that is I think a 6-second delay, something like that. But anyway, frequency varying between 140 Hertz and 230 Hertz, 240 even. So, does this make sense? One frequency only. Well, yeah, I assume it is one frequency only. If not, I don't understand, and I have to do a recap on this way of pulse adding. Alright, now it's even 300 Hertz, so something is climbing up, which may even be that it starts somewhere and it just keeps adding and keeps adding. If that is true, my whole perception of this is wrong. And then, yes, then you may end up in time with a frequency that goes into 16 kilohertz, which I've measured as well. That is a point that I didn't come up with earlier and that I have to investigate. So, I will stop this and I will research on that. After checking on this site which you have seen before, I could not determine anything else. So what we have is a starting moment and a pulse width. And the pulse width says anything because on a pulse width of 1999, no, that's not true. It was the timing that is 1999, not the pulse width. So, how large is the pulse? How large can the pulse be? The pulse width. That's a good one. So, there can be 1999 back to 0, which makes 2000. 2000 moments. But how large can the pulse width be? That is a very good question. So, let me just make 1024, because here I have gone no further than 1000. So let's see how this works out. A point is that the larger the width, the longer the time that it's on. So let me show it like this. The larger the width, the larger the time the signal is on. So let's figure out how long this is going to last. If this is true, oh, wait a minute, like this. Well, 1024 is accepted. Oops, I shouldn't do that. 1024 is accepted. That means that if I am cancelling, no, I should be here, cancelling this, and I change this to, for example, 2048. I'm just going to double it, see whatever happens. Let's go. And this is not possible anymore. 2048. Okay. Down to 2000. Also not possible. Down to 1099, 1999. Alright, so this is interesting. Both the start and the pulse width cannot exceed 1099, which means 2000 width in total. Because if I make this 2000, it's going to have a problem as well. Yes. Which is quite natural, because you have a timing and a time length, and if the length can't exceed 1999, timing can't either. So that is very logical. But in the meantime, I don't see the rotational speed of the what is this? Oh really? 1999 is not accepted. How can that be? Did I do something wrong? Likely. Yes, I did do something wrong. So either this or that is not good. 1998. Okay, this is interesting. And I think I know why. Yes, go for it. Not so much. It doesn't do anything anymore. Oops. Well, for some reason the video stream stalled, so then I have to restart the stream from the receiving player. And you see that it here connects again, and I also have noticed that streaming takes a considerable number of resources on the Raspberry Pi. So whenever that is working, this is going not very smooth, and this is being stalled again, so I have to restart it. Sometimes it works very quickly, sometimes it doesn't, and apparently now it doesn't. Now let's see if, alright, it looks like it's going now. Yes, it keeps playing, which is nice. However, this is not working. So let me change this to 900, see if this is working. And you see that if this is starting, the stream is slowing down. So I think that 1999 can only be run with 0. Yes, it can only be run with 0. Alright. However, that has no effect on the propeller anyway. Well, not on the motor and so not on the propeller. But this is always on. And what I would like to see is not always on. So let's diminish this to, let's reduce this to 1000, or actually what I like is 999. And that is so half the length, so it should run actually half as fast. At timing 0. So let's see if that works out. Half as fast. I have my doubts. I don't see it slow down. So let's measure the speed here. The frequency, that is. Wait a few seconds till you see the probe in view. If it comes. Quite a few seconds delay, I think. Anyway, the frequency is around 150 hertz. Now it's really a large delay now. 10 seconds I think at least. 150 hertz. About that. Going up, going down. So that has no it's not different than when I put it to 50 or whatever. So is this going to be cumbersome? Is this not? I don't know. I know the software is beta. The website tells me it is beta. But then again, if it doesn't do anything, what is the reason? Is the reason this code, or is the reason just that it doesn't work with this motor? Is the software not good enough? Is the combination any combination whatsoever? I can't tell. I will go find out with a different with different software, because I wanted to run. This works with software pulse modulation wiring Pi. So far this hasn't, no matter what I do, no matter what I look for. So what else? Wrapping up this episode. There's no doubt that this LED works. Software doesn't run, but that doesn't matter much. What more? Well, as said, motor doesn't give in, or the software doesn't give in. Anyway, combination doesn't work right now. I will look for a solution, if there's any. I can try using the pot meter again. So here, this pot meter. However, it simply does not work exactly the same as on the Arduino, because my Arduino Mega 2560 does work, and Arduino Uno has shown to work perfectly fine with pulses modulation. Why doesn't it work here? No clue. Have to find out. Wrong motor, maybe servo motor. This isn't a servo motor. Change motor, perhaps, but they run typically on higher voltage than this one. Is it worth a try? Of course it is worth a try. If I can get such a motor, who knows? And if it doesn't work after all, more nice projects to do with the Raspberry Pi. But I want to get it at least once running. For now, thank you for watching what I did do. Measuring voltage, measuring frequency, once again and once again. Getting the stream to work again. Changing software again, which didn't work again. Do I give up? No, again. If you like this video and you haven't subscribed yet, please do so. The number of subscriptions to my YouTube are increasing slowly but surely. If you don't want to subscribe to my channel, to my YouTube, I'm also on Twitter and Instagram. And if you like my videos, please consider to make a donation to keep my blog alive. What more? This is most likely to be continued. Bye bye.